1 minus secant squared, so I have to move this to this side, which would mean I would need to move tangent to the other side. So this would become 1 minus secant squared x equals negative tangent squared x. So the actual answer is negative tangent squared x. All right. Like I said, there's only one person that got it wrong, and they just had positive. They had they had positive instead of negative, but at least no one had the sine squareds or the sines in there. All right. The other way we could do it. Let's say we're in brain freeze mode on the test, and I just don't remember which one goes with secant squared, and I didn't write it down, can't remember it. So the other way we could do it is look at this and tell myself, I kind of want to push it together. But in order to push two things together, they must be in fraction form. So we're going to first put this in fraction form. So another way might be I have 1 minus, and secant squared is just 1 over cosine squared x. Well, once you get to put them together, I need to have a common denominator. So 1 can be rewritten as cosine squared over cosine squared. So I could rewrite that as cosine squared x over cosine squared x minus 1 over cosine squared x. And pushing those two guys together, we're going to get cosine squared minus 1 over cosine squared x. Then we look at cosine squared minus 1. If we think back about sine squared plus cosine squared equals 1, I would need to subtract 1, which would make me subtract sine. So that would actually become negative sine squared x over cosine squared x, which would still equal negative tangent squared x. But I would much rather do this one, because you could probably do it all in your head, versus this one, because it's a lot more steps. But this is sound. This is things we'll have to do to solve problems, right? That's why I wanted to show you this way, because this is how we're going to solve some problems. Any questions on either method that I chose to use? No? All right, then let's get right into questions from the homework. Logan.
Question on 39.
A good question or a bad question?
Like I can't figure it out. I don't know where to start.
Okay, so we have sine alpha, cosine alpha, plus cosine alpha, plus sine alpha, plus 1. That one?
Yeah.
So normally I would have I would create a binomial, right? We're okay with that. I'd create something like this. And normally I'd put something like, sine alpha and sine alpha. But the only reason why I'd put that is so I can get sine alpha squared or sine squared alpha. So we can't do that. We're going to look at that first term. The first term says sine alpha times cosine alpha. So the very first thing we're going to have here is sine alpha times cosine alpha. And then we're going to look at our last term. It needs to be 1.
Okay.
The only thing that multiplies together to give you 1 is positive 1. Positive 1. And then if you check the middle, it does work out.
Okay, that makes sense.
Other questions? Yeah?
Could you go over 37?
37. So 37 is a really good example of why you might want to use factor by grouping, because factor by grouping can do this whole thing for you. I'm going to first, are you going to be upset if I change everything to just x's?
You can go ahead.
Okay, thanks. I was going to do it anyway. So think of this as being 4x to the 4th minus 4x squared, plus 1. I'm going to treat it by factor by grouping. That's why I like factor by grouping. It will get everything set for you. So factor by grouping makes you do A times C, my air conditioning, and my Beyonce column. So A times C would be 4 times 1, which is 4. By B is negative 4. I'm looking for a number that multiplies together to give me 4, but when added gives me negative 4. Sometimes these are the hardest ones to recognize, but it'd be negative 2 and negative 2, because negative 2 times negative 2 is positive 4. Added together gives me a negative 4. The whole reason why we use that is to break apart our middle term. So that'll give me 4x to the 4th minus 2x squared minus 2x squared plus 1. And now all we have to do is group. That's why it's factored by grouping. I'm going to group these two together, and then I'm going to go ahead and group the other two together. And every single time I group, I'm going to pull out that biggest number I can from both of them, our greatest common divisor. So 4x to the 4th, I know I can pull a 2 out, and I can also pull an x squared out of both of them. So I'm going to pull out a 2x squared. 4 divided by 2 is going to be 2x squared left over, and 2x squared pull out of here is just going to be negative 1. The biggest thing I can pull out of a negative 2x squared plus 1, I want this negative between the two, so I'm going to pull out a negative 1. So we have 2x squared minus 1, because I pulled that negative out of that to make it a negative 1. I know I did everything right because these are set up perfectly. Now I just crunch these guys together, and I have 2x squared minus 1, 2x squared minus 1, which is just 2x squared minus 1 squared, and then you just put your secant in place of your x. Does that all make sense? I know I kind of rushed through it.
Yeah.
Yeah. Other questions? That's why I like factor by grouping. I don't have to worry. I just plug stuff in, and it gets it out for you. Questions going once? Going twice? All right, new lesson. We are actually going to verify identities today. We're going to have an equal sign between them. We've been prepping for this day. Like we talked about yesterday, we're just going to pick a side to work on. Usually we pick the most complicated side. Sometimes it's hard to determine because they both look complicated. Then we're just going to simplify that side until it looks like the other side. There are times when you have to work on both sides independently. We'll talk about that. So 3 says write the expressions in terms of sines and cosines. That's one of the tools you could use. If it doesn't look like that's going to work, you might want to multiply the numerator and denominator of one expression by the numerator or denominator of the other. Generally, that's when we're trying to push stuff together, when I want to have that common denominator. If the numerator of the rational expression is a sum, write it as 2 rational expressions. And that was kind of the big thing yesterday, in the fact that if I have sine x plus cosine x over sine x and I can't simplify it any further, I can just pull it apart to be sine x over sine x plus cosine x over sine x. So this is 100% possible because I can add these back together. I just add the numerators. My denominator stays here. Please don't do this. Please don't do this. Let's say I have sine of x over 1 plus cosine of x. This is not equal to sine of x over 1 plus sine of x over cosine. You laugh now, but several of you are going to do this. Several are going to try to break apart the denominator. Could I go back to this? Well, they don't have a common. I would need a common denominator just to put them back together. So this is completely wrong. Don't do it. You're going to do it, but don't do it. All right? It's just a common mistake. I might be accused of doing it at some point, just rushing through something. All right? So just I want to make you aware of, you can split the top. You cannot split the denominator. All right, then it says combine a sum or difference of 2 rational expressions. That's when we push them together versus pulling them apart. And finally, you may have to work on both sides independently. So that means you work one side until you get to a stopping point, and then you work on the next side until you get to a stopping point. Remember, we cannot do stuff to both sides. That means we can't add 2 to both sides. We can't divide some number by both sides. If you want to move to a sign, like sine of x to the other side and it'll work, you can't do that. You have to work on each side independently. And that's why whenever we have something that says verify or prove, in your mind or physically on your paper, draw a divide between the two. Say nothing can happen. I can't carry something over here. It is strictly I can work on this side or I can work on this side. Now, the tip I gave here, if you ever see like 1 plus sine x and 1 minus sine x or any other variation like 1 plus cosine, 1 minus cosine, I'm not talking about there's a squared. If it's just sine or cosine all by itself, it's a good sign that we might have to use the conjugate. It isn't 100% positive, there's multiple ways to solve it. It's just a lot of times the conjugate is the good choice, and we'll see why. So I see I have 1 minus sine theta on one side and 1 plus sine theta on the other side. I can work on either side. They both look equally as complicated. So I'm going to pick a completely arbitrary reason. I'm going to start with the left side. And that's primarily because I put this giant bubble here and I don't really have room to work right here. So that's the only reason why I'm picking the left side. Either one would solve equally easily. All right, so I have cosine theta over 1 minus sine theta. I can't simplify it. So that's a good time to use the conjugate. And how we're going to use the conjugate. So I'm going to stick with that cosine. Oop, got to get rid of that tool. I'm going to have cosine theta over 1 minus sine theta. And I'm going to multiply by the conjugate of 1 minus sine theta. And that's just 1 plus sine theta. So top and bottom I'm going to multiply by 1 plus sine theta. And on the bottom I'm going to multiply by 1 plus sine theta. Until I know for 100% in fact I need to distribute this cosine, I'm going to leave the cosine on the outside. So I'm going to leave it as cosine theta times the quantity 1 plus sine theta. So unless I need to distribute, I'm not going to. On the bottom I have 1 minus sine theta times 1 plus sine theta. That's just a difference of squares. So I don't have to spend the whole time factoring it out. It's just going to be 1 squared minus sine squared theta. Here's the awesome part about the conjugate. Who could tell me what 1 minus sine squared theta equals? What can I simplify that to? Alex? Cosine squared. The whole point of using the conjugate is to get rid of that 1 by changing this to actually cosine squared. All right, so that's going to be cosine theta on top times 1 plus sine theta all over cosine squared theta. And that should be one of those you should start becoming familiar with. All right, you should automatically see those and think it's got to be either cosine squared or negative cosine squared. You just kind of either do the trial and error or just in your mind move stuff around. All right, well that cosine is going to cancel out, and so that's squared. It's just like if you have x over x squared. So we're left with 1 plus sine theta over cosine theta. Now might be a good time to check out the other side. We're done. That's it. How much time did I spend looking at the other side?
0 time.
Not much time. Sometimes you do have to spend a little more time because you can go multiple different paths with it, and you kind of have to guide your way to it. But this one, basically, I just picked one thing to do, and everything else just fell in place. All right, that's how a lot of these work. You just pick the one big thing you have to do in the beginning, and everything else should just kind of fall down from there. All right, any questions on any one of those steps? Okay. Then our next one, we have cosecant x minus sine of x over sine of x equals cotangent squared x. I'm going to put my wall up. Ka-chunk. That's the sound of a wall. I'm going to say that left-hand side is probably the most complicated of the two. But I'm going to look at the left-hand side, and I'm going to say, simplifying wise, I could really only change that cosecant to 1 over sine. And after that, I really don't see what to do next. So maybe that isn't the best starting off plan. What else could we do? What could we do more drastic than just changing that, Will?
Cosecant over sine minus sine over sine.
Say that again?
Can't you just split them off into their own fractions?
Yeah, we could split up in their own fractions. So I'm going to split this up as cosecant x over sine of x minus sine of x over sine of x. Well, sine of x over sine of x is just 1. And now I'm going to convert my cosecant. You might have did all that in one step. You may have turned this into 1 over sine already. I typically try to do one thing at a time so I don't mix stuff up, because as soon as I start doing 2, then I try doing 3 things at once, then I try doing 4 things at once, and all of a sudden I'm trying to get the answer all at once. So we're just going to have 1, maybe I'll write it as a little different fraction, 1 divided by sine of x over sine of x minus 1. And right now I'm going to start thinking about something minus 1 has to equal cotangent squared. So I'm starting to think about cotangent squared and which identity it's in to make sure that I'm doing the right stuff. But we need to simplify this. If you're good with fractions, you realize that it's a fraction over some non-fraction. So we can just multiply the denominators, which would give me 1 over sine squared x. If you're not as comfortable with fractions, you may have to do a little side work and tell yourself, well, keep change flip would be 1 over sine of x, change the sign to multiplication, and flip that bottom thing, which is right now sine of x. The reciprocal of sine of x is 1 over sine of x. And that's why we can just say it's 1 over sine squared x. Well, 1 over sine squared x, I kind of ran out of room. 1 over sine squared x is going to be cosecant squared x minus 1, which if you look at your identity sheet, is going to equal cotangent squared x. And so I don't have to do anything to the other side. Will, did you have a question?
Don't you have to multiply the top and the bottom when you do the two things?
Multiply the top and the bottom. I did. I took the top. I have 1 over sine. I changed this sign to multiplication, and I flipped the bottom. And if I multiply straight across, that becomes 1. Multiply the bottom becomes sine
So you
squared.
don't have to multiply the bottom. I thought you had to multiply the bottom. But, okay, I get it.
I guess we do multiply the bottoms. We do sine x times sine x.
Okay, I get it.
Okay, all right. Any questions on that one? So that one was just, we really just had to break apart the fraction. That was really our big step. All right, the next one, we have 2 tangent squared x equals 1 over cosecant x minus 1 minus 1 over cosecant x plus 1. What am I probably doing in this one? Someone give me a hint at what I should do in this one. I'll give you a hint. It's not anything to do with the 2 times tangent squared x. You don't have to tell me how to do it. You just got to tell me what to do. Yeah.
Conjugate thing where you like multiply by cosecant plus 1. So it's like, in the end, it's like cosecant squared minus 1 on both sides for the denominator.
Oh, I got you. We're trying to create a common denominator, right? So I get what you're saying. I wouldn't have called it as the conjugate, but I guess you are. I would just say I'm just trying to push these 2 fractions together by multiplying by the other denominator. It just happened to be the conjugate, right? So you're 100% right. So I need to push these together, which means I need a common denominator, which means this first one needs to be multiplied by the denominator of the other one. So I need to multiply 1 over cosecant x minus 1. Maybe I should start writing this down. I need to have 1 over cosecant x minus 1. I need to multiply by the denominator of the other fraction, which would be cosecant x plus 1 over cosecant x plus 1. Minus, that minus sign is going to mess us up for a little bit, but we're going to have 1 over cosecant x plus 1 times the denominator of the other one, which would be cosecant x minus 1 over cosecant x minus 1. Now let's just do the multiplications. Our two fractions are going to become cosecant x plus 1 over, this is just a difference of squares, so I don't have to worry about factoring or anything. It just becomes cosecant squared minus 1 squared, or just minus 1, minus cosecant x minus 1 over, once again, it's cosecant squared x minus 1. That minus sign is going to trip up 90% of you. This is a negative sign out front. It needs to be distributed to all parts of either the numerator or all parts of the denominator. It wouldn't make sense to distribute it to the denominator, because then we'd have negative cosecant squared x plus 1, so those wouldn't match up. So I'm going to distribute this to the numerator. So what that's going to leave us with is cosecant x plus 1, distributing this to there is going to be minus cosecant x plus 1 over cosecant squared x minus 1. So simplifying this, our cosecants will cancel out, and we'll be left with 2 on top. So that's the same thing as 2 over cosecant squared x minus 1. Using your identity sheet, you'd realize that this is actually 2 over cotangent. Now I'm going to run out of room. I wrote a little too big. So that's going to become 2 over cotangent squared x, which is the same thing as 2 times 1 over cotangent squared x, which actually is equal to 2 times tangent squared x. And what I do if I run over like that, I just put a box around where I think I'm done. And it matches that one. Any comments or concerns on that one? The most likely thing missed was probably this negative sign, that you don't distribute all the way out. And a good sign that you made a mistake somewhere like that is this would have came out to, so we would have had 0 over this, which would have told you, hey, something's fishy there. All right, so just make sure you distribute your negative signs properly. Surprising enough, algebra is probably going to be the thing that trips a lot of us up. Just the algebra, not the identities, not thinking your way through, is just the algebra that's going to trip us up. All right, last one. This one goes pretty quick. We'll get through it as quick as possible. All right, first thing I'm going to do is get rid of those negative signs. Well, if I have cosecant of negative t, this negative is going to go right in front of the cosecant. So that'd be 1 minus a negative cosecant t. 1 minus a negative is just 1 plus. So we're going to have 1 minus sine squared t over 1 plus cosecant of t. That was just bringing that negative sign out in front. I'm going to go ahead and do the same thing to the other side. I'm going to bring that negative out front. Since it's sine, it gets pulled out front. So we're going to have 1 minus sine of t over cosecant of t. Now you might be able to simplify this side. You can see that we'd already have cosine on top. But then we kind of run out of stuff to do. So I'm going to look more at this right-hand side, especially because it says 1 minus sine of t. It doesn't say 1 minus sine squared. It just says 1 minus sine of t. A good thing to try is conjugates. Conjugates are a good thing to try if you just have 1 minus sine t. So let's go ahead and try the conjugate. So that means I'd multiply the top and bottom by 1 plus sine of t all over cosecant of t. Scratch that. I was thinking far in the vast. It should be 1 plus sine of t on the bottom. That wouldn't have made sense otherwise, because you're multiplying by 1. All right, we have a difference of squares on top, so that's just going to be 1 squared minus sine squared of t. I tend to put t's in parentheses because t's look like pluses. If I was doing this on a test, I would change them to x's or something that I can definitely delineate between pluses and stuff. It is perfectly fine to change the variable I give you. All right, so that's 1 minus sine squared all over, and I'm just going to leave this as cosecant of t times 1 plus sine of t, because I generally don't distribute unless I know for a fact I have to. Unfortunately, we are going to have to distribute it, because look at the top or the numerator of both those fractions. Our numerator is done. That generally implies that just the bottom needs to be simplified. All right, if the top is already done, it just means I need to simplify something in the bottom. It tells you you're on the right path. You did something right to start off with. All right, so our tops, our numerators are the same. I just got to simplify this. So let's go ahead and distribute this cosecant to both items. So that's going to equal 1 minus sine squared t, distributing that cosecant. I'm going to have cosecant times 1, which would be cosecant of t, plus cosecant times sine would be cosecant of t times sine of t. It's definitely looking more like this. I have 1 minus sine squared on top. I have cosecant on bottom. I just needed this to be cosecant plus 1. So my whole hope is somehow all of this equals 1. Will, do you think that equals 1?
Yeah.
Why does it equal 1?
Because cosecant is 1 over sine, and sine is 1 over, or sine over 1.
Yeah.
And if you multiply them, it's sine over sine.
Yep, perfect. Yeah, those actually equal 1. And Will just gave you the perfect explanation, is because cosecant is just 1 over sine. Sine is just sine over 1, which equals 1. So that whole thing just equals 1. And we're done. 1 and done. So we have 1 minus sine squared of t all over, well, it's cosecant t plus 1. I'm just going to change the order to look just like how it started. 1 plus cosecant of t. I am not concerned if you would have wrote cosecant plus 1. I don't care. I know it's the same. Yeah?
Could you just take it one step further and say cosine squared over 1 plus?
You sure could, but as long as it's equal to this one, you're done.
But it doesn't matter if you take
But you have to simplify both sides.
that. Yeah.
You'd have to do it on both sides. So like I said, you may have started this one out and wrote down this was cosine squared, so you would have to go that additional step there. So I would expect to see some of those if I give this on a test. All right, questions for me? All right, remember, these just take practice and practice and practice. I'm going to post the solution key. I think I already posted the solution key to this online the same way I did last time. And that is I'll just take a picture of my examples and put them on. Did that help? For the people that used it? Was it easier than using the book? Okay, then I'll try to keep doing that.